Introducing Blazé Pascal triangle. This is Mr. Pascal. Blazé Pascal is a French mathematician who spotted a pattern in the coefficients of binomial expansions and wrote them down in a triangle now known as Pascal triangle today. Each number is the sum of two numbers directly above it. The triangle is symmetrical, so you only need to work out the first half. This is one term. This is two terms. And this is three terms. A term is called nomial. So nomial equals term. This is one term, one nomial. Two terms, two nomials. You can see the terms are separated by an operator plus. Three terms, three nomials. So now you can see binomial expansion is referring to expansion of two terms. Expansion of two terms to the power of n. And n can be any number, a constant number. Now I'm going to expand the binomial expansion starting with a power of 0. Anything to power of 0 is 1. So therefore, the expansion for this one will be 1. The expansion of x plus y to power of 1 is just x plus y. The expansion of x plus y to power of 2 equals x squared plus 2xy plus y squared. Let's just do one more. The expansion of x plus y cubed equals x cubed plus 3x squared y plus 3xy squared plus y cubed. The coefficient of this expansion for the first one is 1. And the coefficient of the second one is 1x and 1y. Coefficient is the number in front of the variable. So the x squared coefficient is 1. And the xy coefficient is 2. And the y squared coefficient is 1. The x cubed coefficient is 1. And the x squared y is 3 coefficient. And the xy squared is 3 coefficient. And the coefficient of y cubed is 1. Pascal said, of course, I've got 0 here. And I've got 0 there. 0 plus 1 will give you 1. And 0 plus 1 here will give you 1. And then I've got 0 here and also have 0 there. So I've got 0 plus 1 will give me 1. 1 plus 1 will give me 2. And 1 plus 0 will give me 1. For this one, I've got 0 plus 1 here, so that gives me 1. 1 plus 2 gives me 3. 2 plus 1 gives 3. And there's plus 0 here. 1 plus 0 gives 1. So now we could do the next one along. So if I put 0 here, 0 plus 1 will be 1. And 1 plus 3 will be 4. 3 plus 3 will be 6. And 3 plus 1 will be 4. And 1 plus 0 will be 1. So the expansion here will be x to power 4, 4x cubed y, 6x squared, y squared, 4x y cubed, and y to power 4. Of course, plus, 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 plus. So that's the expansion for x plus y to power 4. And so that is the Pascal triangle. He was able to spot the pattern of the coefficients as they form. So here is a more orderly fashioned the binomial expansion because it's 2 terms by nomial, and the expansion, you can see the order, so just go through that again. Oh, don't forget there is obviously 0 here, and then plus 0, 0 plus 1, 1, 1 plus 0, 1, and then you get 1, and then you get 1 plus 1, 2, and then you get 1 again. This time you get 1, 2 plus 1, 3, 2 plus 1, 3, and 1 again. So you get 1 here, and then 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, and you get 1 again, and then you get 1, 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 5, 1, and then you get 1 again. Then you get 1, 1 plus 5, 6, 5 plus 10, 15, 10 plus 10, 20, 10 plus 5, 15, 5 plus 1, 6, and 1 plus 0, 1. So let's do a quick binomial expansion of x to the power 5. So x plus y to the power of 5. I'm expecting x to the power 5 plus x to the power 4, y1 plus x to the power 3, y squared plus x to the power 2, y cubed plus x to the power 1, y4 plus y to the power 5. So the coefficient will be 1, 5, 10, 10, 5, 1. Binomial of x plus y to the power 5. That's that one. These are the Pascal triangle for the power of 0 to 10. The important thing is we could use a combinatorial factorial to generate each component of a binomial expansion. For the first one here, it will be 0 combination 0, and that will be 0 factorial over 0 factorial, 0 factorial, and that becomes 1 over 1 times 1, which is 1. So that's why the first number is always 1. So that one is that one here, because you got 0 in 0, so you get 1. So that's this one here, 0 combination 0. Now we're going to do the second one here. So that point here is going to be 1 combination 0, because that's the start, right? And the second one here will be 1 combination 1. So for that one, this is n combination r, that's what we're using. So that's n factorial over n minus r, open bracket, close bracket, factorial, r factorial. So that's what we're using here. So for this one here, I'm doing the same thing here. For that one, it's the first one because it's 1 combination 0, and this will be, second will be 1 combination 1. So this one is 1, because 1 factorial is 1, and then 0 factorial is also 1. So 0 factorial equals 1, and 1 factorial equals 1. So now if we're going to do that one, so that's the second one, 1, 0, 1. So that's 1 combination 1, so that'd be 1 factorial over 1 minus 1 is 0 factorial, and then 1 factorial, because we're using that. And so that equals 1 again. So that's why these are 1. The third one here, x plus y to the power 2. Again, we're going to use combinatorial factorial here. So this is 3 of them. So it's going to be 0, 1, 2. So now we're doing this one here. So the first one here is 2 combination 0, and that equals 2 factorial divided by 2 minus 0. That's using that formula. Factorial, 0 factorial. 2 minus 0 is 2 factorial. Yeah. So 2 factorial cancels 2 factorial. You got 1 over 0 factorial. 0 factorial is 1, so 1 over 1 is 1. So we're going to do the middle one here. And you got 2 combination 1. So that'll be 2 factorial over 2 minus 1. 2 minus 1 factorial. 1 factorial, using that again. And 2 minus 1 is 1, so you got 1 times 1 at the bottom. 2 factorial is 2 times 1, and that's just 2, so that's 2. And the top one here is exactly the same as that. You got 0 factorial and 2 factorial, so exactly the same, so that's 1. That's why it's symmetrical. Okay, let's try one more. Let's try the third one here. So the third one here, that's the x plus y to the power of 3. The coefficient is going to be 1, 3, 3, 1. So that first one here is going to be 3 combination 0, 3 combination 1, and the third one here will be 3 combination 2, and the fourth one here will be 3 combination 3. So the first one, 3 combination 0, which is the first one here, is 3 factorial over 3 minus 0. So that's 3 factorial, 0 factorial. And that's 1, because 3 factorial cancels 3 factorial. 0 factorial is 1, so 1 over 1 is 0, 1. The 3 combination 1 is 3 factorial over 2 factorial, 1 factorial. As you know, 3 minus 1, that's 2 factorial. And you got a 1 factorial here, because r is 1. And so that is 3 factorial is 3 times 2 times 1, or 3 times 2 factorial. And the 2 factorial, we cancel that 2 factorial, and then you're going to get 3 over 1, because 1 factorial is 1. So that's just 3. This one is exactly the same as that, because even though 3 combination 2, you're going to get 1 factorial and 2 factorial here is exactly the same, and you get 3 as well. And the 3 combination 0, so you get, it is exactly the same as the first one. You got 0 factorial, 3 factorial, but here you got 0 factorial and 3 factorial. It's just switched there, but it's the same thing, and you get 1. So each coefficient corresponds to the combination selection process.